Okay, folks, so if you just watched the last video, I built this potentiometer circuit here, and I twisted the knob, and I used what I call method one, which is just copying and pasting the serial monitor. Now, on my GitHub, I did write this piece of software that what it does is it actually logs data to the disk, right button press. So I have this code here, what it will do is it will record your button press to a file called testdata.txt. And what that allows you to do is that rather than using your computer to copy and paste from the serial monitor, you can actually just write the value to the disk. So what we need to do is we need to just copy and paste this code and kind of unpack it and see exactly what we need and what we don't. So I'm going to delete all this and I'm going to zoom out and I'm going to get rid of the serial monitor, and I'm not going to save yet because what I need to do is I need to load another code called boot.py. Now, if you go to my CircuitPy drive, I have a boot.py file and I have a main.py file. This boot.py file, like, you just need to copy and paste this from my GitHub. So if you go over to data logging, here's boot.py, you just need to copy and paste this and make this file. What this code does, boot.py, is it says if you flip the switch, so if you look at the circuit playground, there is a switch on the board that you can flip left and right. And what this does is if you flip it to true, it will allow you to create data files on the circuit playground, but it won't let you edit code. So you do have to kind of be careful that the switch is flipped the right way, otherwise you can't edit code. And so I'll talk about that a little bit more here. So I'm not going to save this yet because I do want the switch, so I'm going to leave that there. I don't want button A. I do want the LED because I want to be able to make sure that it's writing data. And then I also want to add my potentiometer. So I'm going to do analog IO, and then I'm just going to call it pot analog IO dot analog in, and I'm going to do board A2 because the potentiometer is hooked up to the A2 sensor. Now this says if the switch value is false, open the file for writing, otherwise it's not going to write it. So this basically says don't remount the drive and don't open the text file. If the switch is pulled, it's going to remount the drive and it's going to open a text file. So then down here, we're going to do led.value true, which says like turn the LED on, and then we're going to do time.monotonic. And then at this point, what we need to do is we need to save the digital output, right? And then we want to print the digital output to the serial monitor so we can see it. If the switch value is false, we're going to open a text file, and then we're going to write the data to disk. And what we're going to do is we're going to write the time, and we're going to write the digital output. Now, text files are strings. They're not numbers. So like this text file here it looks like numbers to you and me because we're humans, but to the computer, these are just characters. These are just strings, like A, B, C, D. They're just a character representing a single character. When you use the numpy.load text module, what it's doing is it's converting those strings to floating point numbers. And so here, what we're doing is we're converting floating point numbers to strings, which is why we're using the str function, and then we're outputting that string to a text file. /n just means new line. And then I think that's it. So if I save this and we run the serial monitor, if I hit Control D to reload, it says analog is not defined. Why is that? Oh, because I called it pot. Okay, so then we need to try to do pot.value. Okay, so it's not logging data. It's saying flip the switch and then hit reset. So when you flip the switch, boot.py only runs when it resets the device. So in order to remount the drive, what you need to do is reset the device so it runs boot.py. I don't like that it's not writing very quickly, so I'm going to change this to 0.2. And so that way it's writing a lot faster. And let's just verify that the potentiometer is working. So I'm turning the knob right now and the numbers are going down, which is good. So let's bring it back up to 65,000. Okay. And so let's flip the switch and then hit reset. So I'm going to flip the switch on the circuit playground and it should throw an error. The reason why it threw an error was because the switch was now false, and it tried to write to the output file, but the output file doesn't exist. So now we're going to hit reset on the device. I'm going to get rid of the serial monitor. And then once it boots back up, I see the LED is blinking, which means it's taking data. And if I put this up, it's saying that it's writing data to the disk. So now what I can do is I can rotate the potentiometer. Okay, it's writing this data to the disk, and I can bring it back. And then when I'm done, I'm going to go ahead and say, okay, done. Flip the switch back. Now it's not logging. The drive is still remounted, so you need to reset it one more time before you can actually access the data file. All right, so the LED value is solid on the circuit playground, which means it's not taking data, and there it is, not logging data. But if I run here to my file browser and go to CircuitPy, there is a testdata.txt file, and there is all my test data. And so now I don't need to copy and paste this. I can actually just Control-C this and then throw this on the desktop, and then run over to Tony and then just change data.txt and change that to testdata.txt and run F5, and there is my data. And everything's all well and good and working. And so I think that kind of concludes this video here. So hopefully that helped you with boot.py and storing data to disk. And if you have any questions, post in the comments. I'll see you in the next one.